All right, final video in our series of situations where the integrand gives us a hint on what sort of backward substitution to do. Here's our example for this time. The integral of the square root of x squared minus 1 over x dx. So just like in the last two examples, this x squared minus 1 part is maybe makes us think of Pythagorean trigonometric identities. But if you look at the two identities we used in the previous examples, in this first one with sine and cosine, the negative is on the variable part, but in our integrand, the variable part is positive. The constant part is negative, so that means this first one probably won't work. In the second one, tangent squared theta plus 1 equals secant squared theta, well here there's a positive on the tangent on the variable part and on the constant part. But in our integrand, the constant part has a negative, so that probably won't work either. But actually, with this second one, there's a very easy way to make the constant part have a minus sign on it, and that's just subtract 1 from each side. And that gives us tangent squared theta equals secant squared theta minus 1. So now the right-hand side of this identity is starting to look like the inside of this square root, the variable part squared minus 1. And this is suggesting that the substitution we should do this time is x equals secant theta. All right, so now that we've chosen our x, we can calculate dx. The derivative of secant is secant theta times tangent theta d theta. And now we can do our substitution. We get the integral of, so this numerator is the square root of secant squared theta minus 1 over x, but x is secant theta, times dx, and dx is secant theta times tangent theta times d theta. All right, now we can start simplifying this. Well, right off the bat, the secants cancel. That's good. Nobody likes secant, so we're happy to see it gone. And then inside this square root, secant squared minus 1, well, that's tangent squared according to the identity, and the square root of tangent squared is tangent. Well, it's the absolute value of tangent, but as long as we restrict the domain appropriately, we can just write tangent. Okay, so there will be some caveats on the end. Really, we need to restrict the domain of this to have it correct. Okay, so now we have the integral of tangent theta times tangent theta. That's the integral of tangent squared theta d theta. Scroll down a bit. And let's see, so how to integrate tangent squared. Well, I don't know off the top of my head what the integral of tangent squared is, but, you know, the integral of secant squared is tangent, so maybe it would be good to have secants instead of tangents. And tangent squared, according to that Pythagorean identity, is, let's see, what is it? It's secant squared theta minus 1 d theta. Is that right? Yes, that's right. Okay, and now we can integrate. So integral of secant squared theta is tangent theta minus, and the integral of 1 with respect to theta is theta, so plus a constant. All right, so now we've evaluated the integral, but remember we need to get back to the original variable, and we only have one substitution to undo this time, and that was x equals secant theta. Okay? So let's see. There are two things we need to figure out to undo this substitution. One is, what is theta? So for that one, I'll go up. Just take inverse secant on both sides. Inverse secant of x is equal to theta. Okay? To figure out what tangent theta is, let's go down. So there are a couple ways to do this. I'm going to use the same triangle trick that we used last time. So secant theta is equal to x. X is really x over 1. So we can put all of this into a right triangle. Okay, so if theta is this angle down here, for secant theta to be 1, we need, let's see, secant is hypotenuse over adjacent, so the hypotenuse had better be x, and the adjacent side had better be 1, and that means this opposite side is the square root of x squared minus 1 squared. 1 squared is 1. Okay? And now we can use this right triangle to write down what tangent of theta is. So tangent is opposite over adjacent, which is the square root of x squared minus 1. Of course, you could have also just used that same Pythagorean identity to express tangent theta as the square root of x squared minus 1. So minus theta, but theta is inverse secant of x plus a constant. Okay, that one turned out not to be so bad. We just used the same Pythagorean identity as last time, but we rearranged it a little bit first. So to sum up, there are 3 situations where we can where we know what substitution to use. Okay, so the 3 situations are these. If you have a part of your integrand that is a constant squared minus your variable squared, that is when this substitution works, your constant times sine theta. Okay? If it's your constant squared, if it's the variable squared plus a constant squared, that's when tangent worked. Don't forget to multiply by the constant though. And if you have your variable squared minus your constant squared, that's when secant works out. So those are really the main 3 situations where we know what substitution, what sort of backward substitution to do. It's possible that a backward substitution would work in other situations, but those are the main 3 where there's a clear signal when it is appropriate to do that substitution. Let me know if you have any questions.